Hey guys, Anna Kloppenborg with the EVTV Amsterdam update from New Electric. This week we have a bit of a smorgasbord of lithium iron phosphate batteries for you. Looking at some of the stuff that used to be, that we used to love, that we currently use, and a new kid on the block, so to speak. Over here in the back we have some high power GBS 100 amp hour cells from an early run about four years ago. These came with the much maligned Phillips screw connections. Really, guys, what were you thinking there? Tended to have some spotty performance, or at least these were the rumors I heard, and I would say they are more or less confirmed now that I've taken out 5 cells that are in reverse voltage from a pack in the Beetle that we introduced last week. Then we have our Winston lithium yttrium batteries. My first love and the EVTV mainstay of yesteryear. Winston Chung made these, and they were just a very solid performer. Good, 3C continuous, or at least I did that in the Glastron with not too much problems. 5.5C, 25% voltage sag. She definitely didn't like the cold weather temperature, as I saw in some of the cold weather work I did in the Glastron boat. But all in all, just a very forgiving cell, something that I had some extra experience with because I introduced a lot of heat to a terminal on one of these cells with a bad crimped cable connection that we put a lot of voltage and amps through, rather. And hey, she didn't burn away at all. In fact, that cell still has 93 amp hours between 360 and 2.8. So solid performer all the way around. Then we have our current EVTV champion and darling, really, the second generation lithium iron phosphate cell from Calb, the gray series, CAFI. This cell comes in at an amazing 117 amp hours, so she's good 15 to 20% over spec. She performs admirably well. We all know and love this cell. And then you have her in the 180s over here. You have her in the 100s. The 60 amp hours, a beautiful form factor, and we'll soon be getting our first load of the 40s. EVTV in the USA has had them already. Interesting cell for high volt AC systems, where you're looking at 300, 400 volt, 100, 120 lithium iron phosphate cells. Now you need some of that smaller form factor. So basically, all is well. In battery land, we have a certain price range between, say, your current top of the range, the CA series cells, and maybe your Winston or Sinopoli backup possibilities. But there's a new player at the scene, and it is a German cell from ECC, Reipenning. Reipenning is the name of the gentleman that actually built himself a factory, not about 5 hours down the road here from New Electric, up in northwestern Germany. The Reipenning cell is branded as an EC storage power supply, and this is their 45 amp hour offering. There's a video that I hope to get some subtitles to and clean up a bit, that has an interview with the maker of the factory, Mr. Reipenning himself. And I believe he talks about how a lot of influx of renewable energy, a peak influx with wind and solar, needs to be stored at high power rates, and then needs to be able to be drawn on in same high power rates in a decentralized smart grid solution. So basically, he developed these lithium iron nanophosphate cells in cylindrical format with mostly energy storage in neighborhoods with large supply of solar or wind energy. But now they're opening up their eyes to the different possibilities, both in mobile and fixed applications, and one of the possibilities would be to start looking at these batteries as a source of traction power in mobile applications. They've done some small-scale work with scooters and the like, and are now looking to branch out into real vehicles, as I like to call it. Anyway, so the cell is definitely of German make and quality. I mean, here we've got our "Don't throw away, please recycle" signs. We've are noted to be a 148 watt-hour, 3.3 volt cell. It has barcoding, branding. This is your minus. It's an M8. That's your plus. Once again, M8. So, hey, I've never been the biggest fan of cylindrical for no real good reason, except that I've just always worked with the prismatics, and you can get a lot of them into a box, and you put good connective hardware on the top, and Bob's your uncle. These, obviously, to get a significant amount of them mounted into your vehicle, you're going to need some honeycomb structure. Most likely you're going to be paralleling probably at least 2 of these to make a 90 amp hour group. Why is that? Well, let's put up the data sheet to these batteries. A few interesting things to note. I mean, they're basically keeping to a 2C continuous 5C pulse rating on their data sheet. So nothing really new there. The claim, though, is 5C continuous in a good battery rack due to better ability to thermally get rid of the heat. If you've got air all around each cell, it'll be able to have a slightly higher discharge rate, I would think, just for pure fact that it has a natural coolant area of air around it. One really interesting part is we're saying here 2,000 cycles at 100% depth of discharge, and up to 8,000 cycles, or over 8,000 cycles, at 70% depth of discharge, with 5,000 cycles being in between at 80% depth of discharge, 85% rather. The point of these batteries, supposedly, is that they have an extra guarantee to their cycle life, combined with the fact that now your guarantee is from a German company with a factory 5 hours down the road for us here in Europe, but at least still within the EU for those over in the States, looking to find a partner that has ample supply and production capabilities within one of these countries, in this case Germany. So it makes it an interesting sell. It's definitely not being presented as your new price fighter. When it's all said and done, we're not sure on what the exact pricing is they want on this cell, but I'll definitely work on that for you. But when all's said and done, I think this is going to be your 20-25% premium option over the CA series cells. So it better have some performance to boot, right? I mean, we're not unhappy with our Gray series cells here. So for us to make a leap to a different cell for certain applications, we would like to see a really great performance. So let's get cracking on that. I'll have a setup over in the battery testing corner where I've got a couple more of these EC cells, and we'll get to seeing what they've really got going for them. See you over there. Okay, so here we have 4 of the ray pinning cells in a 12 volt series configuration. The first thing I'd like to see is, if I take them down to a set voltage, how balanced they are out of the box. They all showed a 333, 332 voltage, so it seems like they were really pretty close. I haven't had them up to the Cell Pro yet, so we'll get the last cell hooked up now. Need an extra That's one thing I noticed. Okay, here we go on hooking up the final cell. Can't really, they're M8, but you can't really go as deep as one of the CA series cells. So we need an extra Nord lock or two, especially on the negative. There you go, sorry about that. Should have had it set up already. Okey-doke. So standard setup, Power Lab powered by 24 volt for regenerative discharge capabilities, hooked up via USB to a computer. We have 4 cells in series, each with an individual voltage tap, so we can monitor discharge voltage per cell even though we're discharging in series. And then here we have our software waiting to start. I've set it to discharge at 40 amps down to 2.5. It's seeing our cells. I'm verifying the chemistry. And I'll have to give it a name. And I'll do for ECC 1. And we have very nicely matching voltages right now. 334 behind the comma for all of the cells. And now we're ramping up discharge current. And our discharge voltages are very consistent. Now this is out of the box, right? Literally, I open a box, I hook them up. This is what's happening. So we're now up to the 40 amp discharge rate. We're measuring how many milliamp hours are coming out. We have our cells hooked up in series. Our supply should be able to take it because it was rather low at the moment, so it's doing fine. There's no limiting on the supply, which is getting a regenerative discharge. So I'm going to set it up where we can watch these for a while and see if there's a single cell that hits bottom first, or if these guys come bottom balance out of the box, which would be interesting. Stay tuned. So while we are waiting for paint to dry over in this corner, let's see, that's the new cover that's going into the Delta over here. She is happily charging away with her Brusa at a steady 12 amp rate. Not really fast, but she'll get there, no problem. Is all well in the land of the Delta now that we're all connected back up and we can test our new prop? Well, not quite. I had failed to connect a bolt properly. I missed one bolt out of a couple hundred that we have in here. And in group 38, half of the group wasn't connected properly. That bolt. And that meant that the other half of the group was doing all the work, and as we were discharging the pack a little bit over halfway through the discharge, we reversed the cell that was doing all the work. So we had to take out that group, add in a newly bottom balanced new cell, and over here we have our victim. Red to plus and black to negative, and there we have negative voltage at -0. So she had to come out and we put in a new one. Of course, we had to run down the whole pack and we couldn't really dry run her because we didn't want to heat up the bearings on our new prop shaft mount. So we took our serial discharger, our serial discharge table, the Sol Junior with 3 warp 9s, and we took the pack down. I'm very happy to say that Celso Manaya's bottom balance job behaved beautifully. I took everything down to a 279, and it held there steadily, all 47 remaining groups being perfectly in line. I added back in the original cell and the new out-of-box cell that we also balanced down to 279, holding steady for 24 hours. We popped her all back in, hooked it all back up, turned on the charger, and she is now merrily charging away. And we'll be interested to see if we hit that 0 mark or if we have some calibration issues between charge and discharge, what with low-level use from the DC-DC converter. Anyway, so that's happening in the land of the Delta. When we get half a moment, we'll pop her out into the water and test top speed and temperature management and all that good stuff. Right now, we're waiting on one of these new cells to break a sweat and head off from the pack, if it will. So stay tuned. Okay, so we're back in the corner. We've been called over by the power lab, letting us know that it was done with discharge. I quickly put up a little monitor to catch the bounce back on these cells. But let's stop the monitor, and I'll get us in here. And beep. There we go. And let's bring up the graph, open graph, of the discharge. But all in all, rather balanced, down to 2.7, 2.6 even. So very consistent. That's one thing the Germans like to be known for, their Grundigkeit, which is a very consistent quality. So let's take these cells as they are, and now let's charge them up to 355 from this state. Go. Cell 2 has the lowest recovered voltage at 3.070, and we're going to take them up to 355 and see how many amp hours go in. Oh, I forgot to check how many amp hours went out. I think they were rather full. I think we got at least 40 amp hours out of these cells. Not sure if that means anything, because all we're sure of is that an order of 4 straight from the factory is not really what they're set up for. So these 4 could be specially treated or treated the same as any other when you're getting 400. I'm not sure. Probably it took a little longer for us to get these cells. We were supposed to have them within like a 3-4 day. Turned out to be like a week plus 2 day. Hey, maybe that was because they thought, what, 400 cells? Oh, no, okay, 40 cells? What, 4 cells? Are we even selling these? Who knows what happened there. But as they came out of the box, I had a quite high state of charge, relatively well balanced. Only one cell was a couple 0.0 volts off of the rest. Let's see how much charge they take on their first cycle. Hey guys, I've moved the results portion of the first ECC cylindrical cell test to our upstairs office. It's getting a little chilly down there on the workshop floor. I think the cells were fine as we were cycling them, but the human operator was getting a little cold for comfort. So while I sort out a heating situation to work through the winter down there, I've taken it all upstairs so we can talk a little bit about the preliminary results that I'm getting in with cycling these new ECC 45 amp hour cylindrical lithium iron nanophosphate cells. I'm starting to like them a little bit. They're fun to work with, and our first results are that they are solid little performers, that's for sure. Let's take a little look here. We have the 45 amp hour cell, there's the 45 and there's the 48. That's in the same form factor. I really wanted the 48, and I'll be requesting them for the next time. Anyways, the 45 amp hour cell is coming in at 1,164 grams. That definitely corresponds with the data they have on the data sheet that we'll look at a little later. And then if we add on 2 bolts, Nord locks, and a strap per battery, regardless of the other hardware you'll need to put them into suitable modules of higher voltages, you're looking at about 1,250 grams for the 45 amp hour offering. And I believe volumetrically and weight-wise, the 48 amp hour is the same, so even a little better than that. So we left it at our first discharge and then first charge cycle downstairs. Well, the first discharge was really flat, like we were saying. In fact, at the end, we're talking about a 0.02 voltage difference between the lowest 2 cells and the highest 2 cells. So really, and that's at about 2.5 volt where I did my first discharge at 40 amps. So we can say, pretty much balanced to the norm of bottom balancing on the very first discharge. And we noted that we took out 41.88 amp hours at 40 amps, so basically 1C, straight out of the box. So the state of charge was, let's call it 95% on that very first cycle. So they definitely, either they always ship them pretty much full, or they pre-treated these cells. I'm not sure. Then my first charge cycle, I wanted to go up to 3.6. They, say 3.65 on their data sheet. We're generally a 3.55 kind of crowd. So as I was, editing the settings on the Power Lab, I decided to go up to 3.6. I meant to have it cut off straight away at 3.6, but it did do a bit of a taper current as the first cell hit 3.6. But once again, we can say that at the top, this is no further balancing, straight out of the box after the first discharge, turn right around, charge them at 40 amps, and we're seeing that same, maximum of 0.02 volts of a difference in these cells. How much did they take from a 2.5 at 40 amps discharge to a 3.6 rather 40 amp charge? They took 43.1 amp hours. So after taking out 41.88, I was able to put in 43.1, and that was up to 3.6. They do rate their capacity up to 365. Anyways, these guys, 45 amp hours on the package, and I'll give them 45 amp hours in the data. So that's pretty much consistent, and 1 point for German Gründigkeit, the consistency that they pride German products and German quality to be. So after our full charge, we turn around and discharge now to 2.6 and then cut off. And we see the same flat line discharge, and this is on our second discharge, third cycle. We're seeing that 0.02, very consistent difference at the bottom. So, basically negligible. These cells are, as they came to us, these 4 out of the box, consistent enough in capacity and in state of charge from factory that they would be considered pre-balanced both at the bottom and the top. What makes it extra interesting is that this capacity is being rated on their data sheet as being 2,000 cycles at 100% depth of discharge. Now I try and think of what any number above 100. 1,000 cycles is charging every day a full cycle for 3 years. 2,000 cycles, 6 years, every day, full cycle. Stick these guys in a boat. That must be one work-a-day ship for it to see, full cycles, full use, 7 days a week, 365 a year. So what we can be sure of is that, in any pleasure craft or privately owned car, these guys can be, discharged at 100%, and you're still looking at 10 years of calendar life on your product. Couple that fact with their relatively good performance if we look at their gravimetric density. I got the 45 amp hour cell here, but the same form factor has a 48 amp hour cell that comes in at 158 watt hours instead of 148 watt hours. Anyways, you end up with a 138 watt hours per kilogram rating. So that's basically 0.138 kilowatts per kilogram, which led me to think, well, say that I want to get about 450 kilos worth as a max into my boats. Now we're over 60 kilowatt hours as opposed to probably more around 40 kilowatt hours looking at the Caleb CA series cells. Now we need to factor in a little bit extra probably for the mounting internally to the cell boxes. We're going to have this honeycomb structure, but these guys seem to have a lot of that figured out as well. They already have component numbers for different cell holding brackets and different configurations. So it is looking like, and we'll definitely further discover and ask what their configurations are, but it's looking like we can order most of this stuff out of factory, or manufacture something ourselves. Basically, they have what looks to be Kunststoff. What do we call it? Some synthetic materials to hold the frames, and then straps, and we'll likely choose to use our own braided straps and bolts and Nord locks as connective hardware. So really, the added weight needn't be much at all to hold these cells. And so they shouldn't behave too badly on a volumetric scale. Let's see. We have their cycle life. We have their performance. They're saying 5C for 10 seconds and 8C for 2 seconds as a pulse rating. The continuous, they're saying the same 2C that other modern iron phosphate cells come at, but they do rate these higher C levels on their data sheet, which for instance the CALB doesn't seem to do. We know in effect, in practice, in use, that we can get a good 10C out of the CALB if we so choose, and we will of course be interested to see how these behave at 5 and 10C. So we'll have to devise our own little test bench setup. Any suggestions on that front, shoot us an email and or a comment on the videos, and we'll take a further look. Very interesting to note, early December we are going to visit the factory and have a look around. They make a lot of the fact that they have most everything in the production process automated, that these cells are completely sealed, non-venting cells, so that there's maybe some extra advantage in at least the marketing side of that characteristic, having them in fully IP67 boxes, in boats, and being able to say they can never gas or vent would be interesting. So a lot to look at. I'm definitely interested enough to find out more, and hope you guys will enjoy finding out more with us. That's about it for this week. You guys keep building. We're going to keep building our stuff, and I'll see you all soon. Take it easy.